Hi everyone, today we're going to look at section 10.2, which deals with verifying trigonometric identities. And just as a reminder for you guys, the identities that we're going to use most frequently, just like in the previous section, are the Pythagorean identities. So I've listed those to the right. We have sine squared plus cosine squared is equal to 1. And then when we divide both sides of that equation by cosine squared, we get tangent squared plus 1 is equal to secant squared. And then when we take that first Pythagorean identity and divide both sides by sine squared, we get 1 plus cotangent squared is equal to cosecant squared. So today we have 6 examples that we're going to look at, which deal with verifying the identity. So the first one we have secant squared minus 1 divided by secant squared is equal to sine squared. Okay, so I'm actually going to work this one out two different ways. The first way I'm going to do so, again, we want to start with our more complicated expression, which is the one on the left-hand side. So we have secant squared minus 1 over secant squared. And then we want to manipulate that where using identities and using algebra to where it transforms into the right-hand side. So if we look at the middle Pythagorean identity, if I subtract 1 on both sides, we get secant squared of theta minus 1 is equal to tangent squared, which we're dividing by secant squared. When we look at the right-hand side, that's written in terms of sine only. So I want to take these two trig expressions and get them written in terms of sine and cosine. So tangent squared, we know, is sine squared over cosine squared. If we're dividing that by secant squared is 1 over cosine squared. We can go ahead and divide those two fractions by taking the reciprocal of the second and multiplying, which gives us sine squared over cosine squared times cosine squared, and then those factors of cosine squared cancel. So that gives us sine squared. Okay, so that's one way of verifying that identity. And as I mentioned in the last lesson, you guys only have to find one, but in a lot of these instances, you have more than one way that you can go through and verify the identity. So let's take a look at a second way that we could verify this identity in particular. So we have secant squared minus 1 over secant squared. Another way for me to verify this identity is to take both terms in the numerator and write them over that denominator secant squared. So we're going to take that fraction and essentially break it apart into two fractions, which is going to give us secant squared over secant squared minus 1 over secant squared. And secant squared over secant squared, that just simplifies to 1, minus 1 over secant squared. We can rewrite that as cosine squared. And if we look at that top identity, that top Pythagorean identity on the right, 1 minus cosine squared. So if I take that top one, subtract cosine squared on both sides, 1 minus cosine squared is equivalent to sine squared. So again, both of those approaches would work to verify this identity in particular. Okay, I want to see you guys give the second one a try. So go ahead and pause the video and then turn it back on once you've attempted that problem. Okay, so let's take a look at this one to see how you did. So again, our more complicated expression is the one on the left-hand side. So that's going to be the one that we start with. So that's 1 over 1 minus the sine of alpha plus 1 over 1 plus the sine of alpha. And we want to show that that's equal to 2 times the secant squared of alpha. So again, I want to look at the right-hand side here to kind of give myself a map of where I want to go evaluating this. So when I look at the right-hand side, 2 times the secant squared of alpha, that I can rewrite as 2 over cosine squared, which tells me two things. Number one, that's a single fraction, so I'm probably going to want to write the left-hand side in terms of a single fraction. And secondly, I need my denominator to be cosine squared. Okay, so that's going to kind of guide me with what I'm doing on the left-hand side. So if I want to combine into a single fraction, I need a common denominator. And for me to get that first fraction written with that denominator, I have to multiply the top and bottom by 1 plus sine. So that's going to become 1 plus the sine of alpha. Plus, for me to get that second fraction with the common denominator, I have to multiply the top and bottom by 1 minus sine. Okay, so when I combine like terms in the numerator, the sine and negative sign cancel, which leaves me with 2. And then when I multiply out the denominator, you have something of the form a minus b times a plus b. So that's going to FOIL out to a squared minus b squared, which is 1 minus the sine squared of alpha. And then we can take that top Pythagorean identity. 1 minus sine squared is going to be equal to cosine squared. So this is going to become 2 over cosine squared of alpha, which I can rewrite that as 2 times the secant squared of alpha. Okay, and we verified that identity. Okay, I'd like you to do the same thing for number 3. Go ahead and give that one a try and pause the video, and then you can unpause once you've completed the problem. Okay, so with 3, again, our more complicated expression is the one on the left-hand side. So that's going to be the one that we start with here. Now, I'll work this one out in 2 different ways as well. So for starters, tangent squared plus 1, I can use the middle Pythagorean identity and get that that is secant squared. And then for cosine squared of x minus 1, that's going to become negative sine squared. So secant squared, I can rewrite that as 1 over cosine squared times negative sine squared, which becomes negative sine squared over cosine squared, which is negative tangent squared. Okay, a second way for me to verify the identity is, again, I want to start with the left-hand side of the expression, which is tangent squared plus 1 times cosine squared minus 1. And I'm going to go ahead and FOIL this expression out. So when I take tangent squared and multiply it times cosine squared, tangent squared is sine squared over cosine squared. When I multiply that by cosine squared, the cosines cancel. So that leaves me with sine squared. And then we have, when I multiply the outer terms, tangent squared times negative 1 is negative tangent squared. When I multiply the inner terms, 1 times cosine squared is positive cosine squared. And then when I multiply the last terms, 1 times negative 1 is negative 1. Okay, so to simplify this expression, I can take sine squared plus cosine squared, and using the first Pythagorean identity, that becomes 1, so we get 1 minus tangent squared minus 1, and then when I combine the 2 constant terms, that simplifies to negative tangent squared. So again, that gives us another way to verify that identity.